look at microbial growth, it occurs at two levels. It occurs at the cellular level and this is how they increase in size, and then it also causes an increase in the number and the population size. Main way that bacterial cells divide is through binary fission. This is where the parent cell enlarges, it duplicates its chromosome, it forms this central transverse septum that divides the cell into two daughter cells that are identical. It is an asexual process. You see at the top it's starting with one and it's doubling its chromosome, and you see how it's pinching in and forming the septum, and down here we have two. They are identical, and within 24 hours one cell can result in 5,100 tons of cells. So it happens very rapidly. Now, the time required for complete fission cycle is the generation, or the doubling time. And the growth pattern is what we call exponential because it doubles with each generation. So each new fission cycle increases the population by a factor of 2. That's exponential growth. And the generation times vary from minutes, around 20 to 30 minutes, to days. So here you can see we start out with one cell, and then we have 2, and then 4, and then 8, and then 16, and 24. 5 generations have occurred. So we're going to learn how to figure this. And here you have a logarithmic scale that is going to be this dotted line, and the arithmetic scale is the curved line that you see there. If we rate their population growth. Okay, here's the equation for calculating population size. NF, that's the total number of cells in the population. The NI is the starting number of cells, and that exponent n denotes the generation time. Remember, it doubles with each generation. So 2n is the number of cells in that generation. So if we want to know how many bacteria will appear in potato salad in 1 hour, and we say we start out with 100 cells, so Ni is 100. And I tell you that your doubling time is 15 minutes. So how many generations can we produce in 1 hour? If it's 15 minutes, we can produce 15, 30, 45, 60. We can produce 4 generations. So it's 100 multiplied by 2, and the exponent is 4. So it's 100, not divided, multiplied. 100 multiplied by 2 exponent 4. 2 exponent 4 is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 2 is 1 generation, 4 is 2nd generation, 8 is 3rd, and the 4th is 16. It doubles every time. 100 times 16 is 1600. That's how many bacteria appear in potato salad in 1 hour with a doubling time of 15. You will have to do one of these on your test. So our concept check, we've got the E. coli, doubling time of 20 minutes. So how many times can it double in an hour? 20, 40. Okay, it can double 3 times, right, in an hour. So if you start out with 5, how many will there be in 3 hours? Okay, we can double 3 times in an hour. So 3 times 3 hours is 9. So we're at 2, the exponent is 9. 5 times 2 to the exponent of 9. So we go 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That's 4 generations. 16 times 2 is 32. That's 5. 32 times 2 is 64. That's 6. 64 times 2 is 128. That's 7. 128 times 2 is 256. 5 times 250, oh, not 256, is that right? I think it's right. All right. 2 times 2 is first generation, 4 is second, 8 is third, 16, 32 is fifth, 6 is 64, 7th is 128, 256, that doesn't seem right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got to go 9 though. So 256 is the 8th generation, and we go by 2, multiply that by 2, then we get 512. So 5 times 512 equals 2560.